it is applicable, don't write this, it is applicable for all kinds of triangle, okay, but our use case is right angle triangle. So we will be using trigonometry for a right angle triangle. So it's not that it's only used for a right angle triangle and not any other triangle. Most commonly for a right angle triangle. All our analysis will be on right angle triangle. Okay. So first let us study about right angle triangle and what are the different sides called. Then we'll move forward. Okay, this is very important. So in a right angle triangle, so one angle will be 90 degree, correct, no? Angle A, angle B, angle C. The three sides or three angles. One angle is 90 degrees, I'll call angle B is 90 degrees. Now, what is this side AC called? It's called the hypotenuse. So what is hypotenuse? The side opposite to 90 degree is always hypotenuse. The side opposite to 90 degree is always hypotenuse. So in this case, this is hypotenuse. Let me call it hyp, HYP, hyp. Now, in trigonometry, there will be one more angle. Okay. I can denote that angle here or here, okay, and I'll call that angle by this term. What is this? It is called as theta. Okay, this whatever you write like this, no, O or whatever you can call it, it's actually theta. Theta is a Greek letter for angle. Theta means angle. It's used. Okay, so nothing much. There is no rocket science behind that. Theta means angle. So if I want to denote any angle, I denote it with the letter theta. Okay. Now, the side opposite to theta is called as opposite side. Okay, the side opposite to the angle that we are concerned is called as opposite side. Side opposite to 90 degrees is called as hypotenuse. Side opposite to the angle that we are concerned, that is theta, is called as opposite side. The remaining side is called as the adjacent side. This identification everyone should know. So what is hypotenuse? The side opposite to 90 degree is called as hypotenuse. Side opposite to the angle theta is called as opposite. Side opposite to the side other side, remaining side is called as the adjacent side. Okay, let's draw this. You don't have to draw the arrow. Means opposite to 90 degrees. Okay, now that is, if I take this angle as theta, these are the three sides. Okay, now I'll draw one more triangle. Okay, I'll draw one more triangle. Again the same notation, A, B, C, and I'll take this angle as theta. Okay, now what is hypotenuse? Hypotenuse will remain the same because hypotenuse is nothing but side opposite to 90 degrees. So hypotenuse will remain the same. But what about opposite side? Opposite side is this. The side opposite to theta is the opposite side. So this is opposite. So this is opposite. The remaining side will be adjacent. So don't fix this thing like, okay, this is hypotenuse, this is opposite, this is adjacent. It's not like that. It depends on where you take the angle. If you take this angle as theta, this is opposite, this is adjacent. But if you take this angle as theta, this will be opposite and this will be adjacent. Okay, so don't fix that thing in your head that okay, this is always opposite, this is always adjacent. Nothing like that. Okay, it changes with the angle. Draw this one too. Done with this? Okay. Now, next we'll go to trigonometric ratios. First thing is identification. You should know which is hypotenuse, which is opposite and which is adjacent. Next thing is using them, we can write trigonometric ratios. Okay. There are 6 different trigonometric ratios. First I'll give their names and then we'll see what they are. Okay. They are sine, cosine, tangent, cosecant, secant and cotangent. So these are the names given to the trigonometric ratios. So trigonometric ratios are 6. What are they? Sine, cosine, tangent, cosecant, secant and cotangent. Okay. So if I take any triangle, right angle triangle, okay, I can apply trigonometric ratios to that. Okay. So I'll write the sides again. Let me take this angle as theta. This will be hypotenuse, this will be opposite and this will be adjacent. Okay. Now, these are the names, okay. But when you represent them using formulas, you don't write the entire word. You cut them into half or you leave out some. Okay. Sine actual spelling is SINE. Okay. But when you write them in terms of a formula, you don't write entire SIN. You just write SIN. So now SIN is sine. Okay. If I apply right here, sine theta, sine of the angle. Okay. The ratio will be opposite by hypotenuse. Okay. Sine theta, a sine of any angle is nothing but opposite by hypotenuse. So sine, don't write, we'll write it later. Opposite by hypotenuse. Cosine also, the entire word is cosine, but when you write it in terms of formula, you just write cos. Okay, so cos theta will be equal to adjacent by hypotenuse. Okay, sin theta was opposite by hypotenuse. Cos theta will be adjacent by hypotenuse. So cos theta will be adjacent by hypotenuse. Now, again, tangent is the full word. We don't use full tangent. We just write tan. So tan theta. So tan theta will be simply, you just have to divide this and this. So when you divide this and this, what will happen? Denominator will cancel. Correct? No? Hypotenuse and hypotenuse will cancel. So what will remain? Opposite by adjacent. Opposite by adjacent. Is that correct? So these are the first 3 trigonometric ratios. What are they? Sine, cosine and tangent. Sine in short we write sine theta, sin theta. And that ratio is opposite by hypotenuse. Cos theta will be adjacent by hypotenuse. Tan theta will be opposite by adjacent. If you know these 3, next 3 are very simple. Cosecant, in short we call it as cosec. What do we call? Cosec. So cosecant of theta means cosec theta. It is exactly inverse of sine. It's exactly reciprocal of sine. If sine is opposite by hypotenuse, cosecant will be hypotenuse by opposite. Same way, secant, we call it sec theta. It is equal to, if this is adjacent by hypotenuse, that will be hypotenuse by adjacent. Then cotangent, we call it as cot. Cot theta is equal to, it's exactly opposite of tan. If tan is opposite by adjacent, cot will be adjacent by opposite. These are the 6 trigonometric ratios. These are the building blocks of trigonometry. These are ABCD of trigonometry. If you know this, you can frame sentence or you can go further. If you don't know this, you can't do anything. Is that clear? So what are these? These are called as trigonometric ratios. So how many trigonometric ratios are there? 6. What are they? Sine, cosine, tangent, cosecant, secant and cotangent. So sine theta will be equal to opposite by hypotenuse. Cos theta will be equal to adjacent by hypotenuse. Tan theta will be equal to opposite by adjacent. Cosecant theta is exactly inverse of sine. So cosecant theta is equal to hypotenuse by opposite. Secant theta is exactly inverse of cos. Secant theta will be equal to hypotenuse by adjacent. So cot theta is exactly inverse of tan. So cot theta will be equal to adjacent by hypotenuse. You just need to know these three. Then you can easily get the other. Is that clear? These are trigonometric ratios. Just write this.